Hi everyone. In this lecture series, we are going to see about the substitution techniques. We are having some of the substitution techniques. The first substitution technique is the monoalphabetic cipher. So here we are taking the alphabets from A to Z and we are going to assign the numbers from 0 to 25. Suppose if we want to substitute the alphabet A in numbers, we have to represent as 0. If it is B, it will be 1. If it is C, it will be 2. So mathematically, we are having 26 alphabet permutation, which means we are going to multiply 26 into 25. So which is about 4 into 1026 possibilities. The next one is homophonic substitution cipher. So here we are going to replace an alphabet with a key. For example, if we are using A, suppose if we want to change the value or the key, so instead of A, we can replace H, J, O, P and B, whatever it may be. Suppose if, for example, if we take the word help, so H may be replaced as A, E may be replaced as D, L may be replaced as Z and P may be replaced as O. The same alphabet should not be repeated. Here we are using a fixed keys and with the help of the keys only we are going to replace. The next one is the polygram substitution cipher. In this polygram substitution cipher, instead of replacing the one plain text, we simply replace the block of the word. So we are not going to change the word separately, but we are going to change the word. So suppose suppose for example, if we take an include help, so we are not we are going to change all the alphabets, but instead of that whole word, just we are going to take the help alone and we are going to replace this. So here the four last letters are the same, but the words will be in the form of the different. Suppose for example in include help, if we are going for the polygram institution, the INCLUDEHELP, the alphabets may be replaced into WDSAEQTGTAI. So in that include help, we are taking only the help, it is a word, so that has been converted into RYCV. So that is termed to be as your polygram substitution. Here we are taking the word and we are converting. The next thing is we are going to see about the transposition techniques. So here the transposition techniques, it is an encryption method. So here we are going to performing the permutation over the plain text. So here mapping plain text into the cipher text using the transposition technique is called transposition cipher. In transposition techniques, we are having the various types in that rail fence transposition, column transposition, improved transposition, and the last one is the book or running key cipher. The first one we are going to see about the rail fence cipher. It is one of the simplest transposition cipher. We are having some of the techniques. The plain text is written as a sequence of diagonals, and if we want to obtain the cipher text, the text is read as the sequence of rows. So if we want to see an example, suppose here I have taken the plain text as meet me tomorrow. I have to convert this meet me tomorrow into cipher text, but the text what we are having in the plain text should be right in a diagonal form. So here look at the image, we know that it has been written in a rail fence. So the first letter will be M, the next letter will be E, again it will be E, T, M, E, T, O, M, O, R, or O, W. But it why the name it is rail fence means it looks like a rail fence. That is what now the plain text should be converted into ciphertext. In this example, we are having the plain text as meet me tomorrow, and if we write the meet me tomorrow in the railways technique, the plain text should be converted like this. So once we are going to write the message as the sequence of diagonals, the same thing we have to read as the sequence of row. So the first row we are having MEMTMRO, the second row we are having ETEOORW. So we are going to complete the ciphertext. What we will do, so we have to write the first half of the cipher and the second half of the cipher. Now the plain text what we have written is meet me tomorrow, that has been converted into ciphertext as MEMTMROETEOORW. So the next one is the columnar transposition techniques. So it is nothing but we are taking an example as meet tomorrow. So here we have to define in the form of the rectangle, and it should be 3 cross 4. So here it should be in the form of the rectangle, and we can assign the order such as 1 2 3 4. So whatever the column we are having in the first row will be written at the first. So this is termed to be as your column transposition technique. The next one is the book cipher on the running key cipher. So it is based on the principle of one time. Suppose if the key is taken as long as the plain text, it is discarded after the use. So a new key is taken for the new message. Suppose I want to convert the plain text into the ciphertext. Suppose I am giving the numeric form meet tomorrow. So already I said that suppose if the alphabet is A, it will be assigned as 0. If it is B, it will be assigned as 1. The same thing we have to write for each alphabet. The 12th letter will be M and the 4th letter will be E. Likewise, we have to write for the alphabets from M to W. The next we have to assign some numeric form key text. So this will be an encryption, it will be the key text. The next thing we have to add the numeric and the plain text. So here the first alphabet M equal to 12, the next alphabet will be 0. So we have to write like this, and we have to add all the numbers. If it is E, it will be 4. If it is N, it will be 13. So 4 plus 13, it will be 16. Likewise, we have to write all the numbers. So here we have to find the alphabets for these values. So if it is 25, it will be Z alphabet. But here the numbers are more than 25. So we have to subtract the number by 26. If it is the largest number than 25, we have to subtract 32 minus 25. It will be we have to subtract that value, and new ciphertext will be framed. So likewise, we have to find all the data for the running key cipher. Thank you.